Welcome back. This is the video for Lab 4 of the Building a DNS Infrastructure for Wired Brain Coffee Incorporated. In this video, you're going to learn how to build a public DNS infrastructure and learn how different it is than building a private DNS infrastructure. Within this video, you're also going to learn how to create resource records for your web server, FTP server, and mail server, as well as learning how to set up round-robin DNS. One of the first things we want to do is differentiate between what we're setting up and what a real-life public DNS infrastructure would look like. So I'm going to refer to a couple of the diagrams that are in your lab book. And the first one we're going to look at is your lab setup. Let's explain what this actually means. So let me enlarge this a little bit, get a better picture. Okay, this will work. What we see here is marked external and internal, or we could also mark it public DNS infrastructure, private DNS infrastructure. Now within our lab environment we have one hub, there's no firewall, so we don't truly have a public and a private network. What we're going to set up is 3 different computers. This is client 1, it's going to be part of your internal network, as well as SRV1. This computer here is going to be hosting the internal DNS. This computer over here, SRV11, will be hosting the external DNS, or the public DNS that would be available to the general public. Let's take a look at the other diagram we have. And this is more of a real network DNS. So let's take a closer look at this one as well and try to differentiate between what we see. Okay, this section over here, once again, is our internal or private DNS. So we've got that same client computer. Here's SRV1 acting as the primary internal DNS server, and SRV2 is just another domain controller we throw on the network. This firewall is here just to designate to you that this portion is the private network and this portion is the public network. On the public network we see a web server, www, that's also hosting FTP services. We have a mail server that sometimes can be found on the public side or sometimes can be found on the private side. We just have it in the public in our case. And here we have SRV11, who's hosting our public DNS. Okay, and we're going to talk a lot about how this is set up. But when we go through this lab today, what we're going to be doing is pretending this is what we have set up. In reality, back to this diagram here, this is what we have set up. So you're going to have to emulate the fact that this here is actually part of our public DNS infrastructure that we see over here. So this is going to be the DNS server that's sitting here. This computer is going to have a public IP address. I'm going to talk more about that here in a second to be able to communicate with all the different computers out on the internet. Okay, one of the first things we need to do before we get started is clean up our messes from Lab 1 through Lab 3. And the reason we're doing this, just to make sure that we're all on an even playing field when we start up this lab. So we're gonna delete all the zones off of SRV1 and SRV11 to start with. So I'm going to log on to SRV1 using terminal services. So we're now on SRV1. Open up DNS. Let's check our zones here. And we do have a wiredbraincoffee.com zone. So we'll delete this. And let's delete the reverse lookup zone as well. Delete. Okay. So when we look now, we've got no zone at all on SRV1. So let's close this. We'll log off this machine. Okay, so we get back here to client 1 right now. And now we're going to log on to SRV11. So if you're doing it at home and you're not using terminal services, you're going to be doing the equivalent, but you're going to be logging on to the separate computers and doing the same thing. So I'm connecting to SRV11 now. I'm going to open up DNS once again like I just did. Okay, drill down here and we're going to get rid of this portland.wiredbraincoffee.com zone and also our reverse lookup zone. Okay, we'll double check over here. Okay, looks like we're all cleaned up. So let's go ahead and close this. Then we'll log off here and get back to client 1. Okay. Now let's go take a look. We're first going to configure our external DNS server. So I want to take a look at this diagram and go into some more of the details that are necessary when you're configuring external or a public DNS server. So SRV11 is going to be the first server that we configure. And as you see here, once again, it's on the public side of my firewall. So some things that we need to think about. First off, this computer is going to be directly exposed to the internet. So we need to be very careful about how we're going to handle this setup here. Meaning we're going to have to make it more secure. We're going to have to lock this system down and make sure we have a minimal number of services to make this system as secure as possible. Another thing to mention now, and we'll reiterate this point throughout this lesson, but SRv11 and SRv1 are both DNS servers for our wiredbraincoffee.com domain. The difference is, though, SRv1 is going to hold its own zone database internally for Wired Brain Coffee. So it's going to have no relation to the wiredbraincoffee.com database that's held out here. So SRv1 will hold a database of all the internal host records. SRv11 is only going to hold a database that includes, for instance, the IP address of the mail server and the IP addresses of the www and FTP servers. Okay, so that's your main difference. Zone transfers will not occur between these two different servers. Okay, and this is where we get our split brain or split DNS. We're using the same domain name, wiredbraincoffee.com. This one holds wiredbraincoffee.com and this server holds wiredbraincoffee.com, but they're not sharing the zone, so they're not transferring back and forth between them. Okay, so that's a pretty good explanation. We'll go into more depth, like I said, throughout this lesson. Next thing we need to talk about here. These computers out here must have public IP addresses. All right, all the computers behind the firewall, they're probably using some sort of private class IP address, such as 192.168 or 10.0, whatever you use. Out here, though, for these computers to be on the public network, we have to obtain a public IP address, most likely from your ISP. Okay, so, and that depends upon how many public IP addresses you need. You can't just freely use any public IP address you want. Okay, that's how the TCP/IP infrastructure is set up. So each public IP address is a unique number that a particular company can use. So that's my first task, is to obtain public IP addresses from the ISP. Once I've done that, I'm going to assign a public IP address to each one of my computers out here. And we're going to be focusing, obviously on DNS here. So we're not going to talk much about the configuration of the www or the mail server. But for the DNS server, we do have to have a unique public IP address. Once we have that set up, our next task is to get in contact with the registrar where we registered our domain name. So for example, wiredbraincoffee.com, to actually reserve that for my company, I have to go out to a company like Network Solutions or GoDaddy, which is a alternative to Network Solutions, much cheaper for a domain name. Go out to a company like that and actually register your domain name. So once I've done that and I've registered wiredbraincoffee.com, I need to tell my registrar to point DNS requests out to my DNS server. Okay, so let me repeat that. This isn't necessarily done through your ISP, but it's done through another company such as a Network Solutions. We'll just focus on them. They're the oldest and the biggest, I would still say, at this point. So Network Solutions, then, when you first register your domain name, any request for, and we'll just use obviously wiredbraincoffee.com, any request for that domain name will go to Network Solutions, and they're responsible for any name resolution. You can take over that DNS resolution process, though. And this is all automated now. You can do this online and configure Network Solutions to pass any DNS resolutions for wiredbraincoffee.com down to your DNS server, but this has to be set up. Okay, so those are the, I guess, 3 prerequisite steps that we need to talk about. First, this is public. You need to lock this down and secure it. 2, this computer needs to have a public IP address. And 3, whoever you register your domain name with, they need to be informed, and it has to be configured so they pass all DNS requests down to your actual DNS server, because this server, is on your premises. You're now responsible for these 3 servers. Okay, so that's the first thing we need to do. Let's go take a look at how we're going to configure this DNS server. And we're going to be setting this up on SRv11. So we'll use terminal services to connect over to SRv11. So I log on here, and we'll open up DNS. Okay, so I'm going to get rid of SRv1 here so we don't have this here anymore. Once again, I repeated this, or I mentioned this in a previous lab. What I just did, I deleted that reference to SRv1 out of this console. It's not like deleting SRv1 permanently or uninstalling DNS. It's just taking it off this particular DNS console that I'm looking at right now. So I'm only working with SRv11 at the current moment. First thing I'm going to do, I've got to create a forward lookup zone on the actual public DNS server, just like you would on any internal DNS server. So we're going to walk through this process. I'm going to explain some different concepts as we're going through here. Standard primary. Very unlikely it should be using Active Directory integrated on the public DNS side. Okay, you don't really want to have a domain environment on a public network, so you wouldn't have that on the outside of the firewall. So almost always you're going to be using standard primary DNS servers on the external side of the firewall. Okay, the zone name. So we're using wiredbraincoffee.com. Okay, wiredbraincoffee.com. Looks good, just like we have been. So it's, this part should be absolutely no different. Okay, so nothing new there. This is stuff that we've seen already. What is different, though, what we need to talk about, is the actual IP address that's assigned on SRv11 right now. Okay, and we'll go take a quick peek here first. Okay, right now we've got it set up so it's absolutely no different. Okay, and obviously the IP address needs to be changed. We're going to leave this at 192.168.1.211 just because we're in our test lab environment. If this were a real public DNS server, we'd have to change this IP address. And once again, this would be one of the IP addresses that you obtained from your ISP. So I may have obtained 5 public IP addresses. I can use one of these right here on this computer. Okay, so that's the first thing to note. Let's close this down, go back into DNS here now. And any computer on this public DNS, so I don't have the diagram right here, but the web server, the FTP server, the mail server, and the DNS server, each one of those computers, not only would they have to be configured with an IP address, a public IP address and TCP/IP, but all the host records are also going to reflect that. And that's one difference you're going to see when we start going through right now and creating these host records. So I'm going to create a reverse lookup zone using our fictitious private class IP address. Oops, 1. And this, once again, this would be reflected with whatever IP address you're actually using. So we're not using this in the public for real, but that's what we're going to set up for right now. So we see SRv11 already listed. We're also going to create host records for a couple other records here, a couple other computers. We set it up for www. And we're also going to set up for the mail server. So let's get this one in first. And we'll create a PTR record, so this will be done automatically for us. And let's do one for our mail server. That's going to be at 251. Also create an associated PTR record, add host, and we're all done here. Okay, so we see our host records for the public wiredbraincoffee.com zone. And what we have here, just to make sure that you understand this, is if you have a private DNS client on somebody else's network looking for www.wiredbraincoffee.com, keep in mind how this is going to work. They're going to be referred to our registrar. Let's say it's Network Solutions, and Network Solutions has the DNS server, our DNS server's IP address configured on it because we set it up that way. We went out to Network Solutions and told them, hey, we're going to host our own DNS. Here's the IP address of my DNS server. So start pointing anything to wiredbraincoffee.com to my DNS server here. Okay, so that's SRv11. What's going to happen then when our server gets wiredbraincoffee.com configured on it, we've got the www host record here. So when a request comes into our server, SRv11, for www.wiredbraincoffee.com, we're going to return the entry 192.168.1.250, or whatever the public IP address would be for the www entry. So that's then supplied back to the private DNS client that's on somebody else's network, and they can connect directly to our web server over the internet using the IP address then. Just to give you a little bit of insight of how that actually works. Okay, let's talk about a couple other things we need to think about with a public DNS server. And one of these is our forwarders. Now we still have this setting left over from a previous lab. This isn't in here automatically by default. Remember, normally we see something like this. We need to, it's actually like this. We need to enable forwarders first. Okay, and when I check enable forwarders, I'm then able to configure a forwarder in this space here. And right now the IP address you see is a public DNS server. It's for my ISP's DNS server. So what we want to talk about is what entry do we actually put in here. And in this case, this IP address is appropriate. Okay, I've got a public web server, public DNS server, excuse me, that's sitting out in the internet, and I need some way to forward any request off, because this, keep in mind, this server can only process DNS requests for wiredbraincoffee.com, and it only has right now 3 different resource records in here, so it can't really do a lot as far as name resolution is concerned. So it's going to have to forward off name resolution requests somewhere. Let's take a step back though and explain in more detail why we need that. Back on client 1, and what I want to look at is the diagram. Open this up, and here we are on our public DNS server, and this is the real-world diagram of wiredbraincoffee.com. Now, this server itself doesn't need to have a forwarder when we have external clients coming in to look at our website, because these external clients are going to be referred to, let's say, Network Solutions. They're going to be pointed down here to SRv11. Within our zone, we have an entry for www. So we're able to supply that IP address back to the client that's sitting out here, and they can talk to our server directly. So we don't need a forwarder configured for that reason. We're getting ahead of ourselves a little bit, but when we get into configuring the private DNS server, what we need to do is set up some way for this DNS server to access publicly accessible DNS servers. Otherwise, our client computers internally will only be able to access resource records within these DNS servers, and they won't be able to access the internet. So what we'll see is this client computer will connect to this DNS server. This DNS server is going to forward off to this DNS server, our public DNS server, and without configuring a forwarder here, this computer would be stuck. Recall, we just looked at its zone, and there's only 3 records in there, and none of them are for public websites that they might want to, view. So what we do is configure a forwarder that passes on to another DNS server, and that's what you see here. The forwarder configured on SRv11 that we just looked at is forwarding on to the ISP's DNS server. Okay, and that's for the benefit of all of the internal clients. Okay, so let's shut this back down, go back out to SRv11. Okay, so we would want to set that, and probably don't want to use recursion either. You want to just have this computer refer to somebody else. And remember what this is. If you make this setting, check this box, do not use recursion, you're turning this DNS server into what's called a slave server. So this server is not going to attempt to go out and resolve DNS resolutions on its own. What it's going to do, it's always going to forward out to 207.69, 188, 187. If that doesn't work, it's just going to return a host not found record to whoever made the request from it. Okay, next thing we want to look at. Let's go ahead and close this. And this time we're going to go to the properties of the zone itself. And a couple settings that we will have different on a public DNS server that necessarily would be different on a private DNS server. Let's make sure that we have these set correctly. First one we're going to look at are dynamic updates. Okay, and normally we showed you, previously how to enable dynamic updates. It's a real good feature for a private DNS. Okay, on a public DNS server though, it's not a real good idea. If you allow dynamic updates, this means that any client computer that connects to you will be able to create a host record within your zone. Okay, so if I leave this setting on yes or change this setting to yes, any client computer out in the internet, public network, can connect to this DNS server and register itself, create a host record just like I see here on this DNS server, which is a big security hole. So we want to make sure that this is set at no, and we'll move forward from there. Another thing we want to take a look at is our zone transfer setting. Okay, allow zone transfers. By default, this is set to any server. Another no-no. This DNS server right now in our situation is sitting out there by itself, so it shouldn't be transferring out to any other DNS server. Now on a real public network, you're most likely going to have at least a second DNS server for your public, DNS name resolution. So what we might want to do is select this option, only to servers listed on the name servers tab, and specify that second DNS server that we're going to be, transferring with. Okay, so we could do it that way, or we could just say only to the following servers and actually give the exact IP address of that one particular server. So the key here, though, don't leave this onto any server, because if you leave it there, then any server can set up as a secondary DNS server of the zone and transfer all of your information straight from this DNS server down to that DNS server. So that's something you definitely don't want to do. Okay, the next thing we're going to look at is how to create a CNAME record, also called an alias record. Okay, and a reason to do this. Let's go back and look at our diagram here briefly. Recall that we have one server here, and on this server we're running a couple different services, web and FTP. And typically, if you're an internet user, you connect to a website by going to www, and you connect to an FTP site by going to FTP. So you're opening up Internet Explorer in either case. If you want to connect to the FTP server here, though, you'd probably type in ftp.wiredbraincoffee.com instead of www. So to set this up so it works correctly, let me connect back over here real quick. What we can do is create an alias record. Alright, so to set this up, I'm just going to go here and go to New Alias, and you should know this by both of its name. New Alias is one name. It's also known as a CNAME or canonical name. So the alias name we're going to use, FTP, it's easy enough. And this is different than what you're used to. Normally, remember with a host record, you actually specify the IP address here. Well, with an alias record, you go out and you browse for the host record that you want it to connect to. So I'm going through the SRV11 forward lookup zone for wiredbraincoffee.com. Here's the record, www, so I click OK. Confirm it. Click OK again. And now here, when we look into our different resource records, slide this over here. Look what we have. We have a www record, so anybody who comes in and types www.wiredbraincoffee.com is going to receive this particular IP address and will connect to this computer. But if somebody's looking for ftp.wiredbraincoffee.com, they will also connect to the FTP server, and instead of having to create a separate host record, now we can set up an alias record that's just going to map to this host record. So they'll ask for FTP, and what will end up happening, we'll go through here, which will reference this record, and they're ultimately going to get the same IP address. Aliases are very helpful in a case where you may have a lot of different computers or services running on one computer that you want to alias out. And it's helpful because if we set up, let's say, even 5 different resource records, and then we change the IP address of a system, we'll have to change 5 different IP addresses, so it can be a little bit more difficult to manage. With alias records, doesn't matter what I change this IP address to. I could change this to 255 right now. I'm not going to, but if I change this to 255, it'll change this record, but if you look at this record, I won't have to change it. It's still referencing www.wiredbraincoffee.com, so it's referring to the actual host name, not the IP address. So that's the advantage to using alias records. I could have 5 or 10 different aliases all pointing to this one host record, change this IP address anytime I want, and I don't have to change the other 10 alias records that I created. Okay, another record we can create here. We have a mail server. Okay, Microsoft Exchange server, if you're not familiar with that, just a common mail server that you can use. And what we're going to set up is what's called an MX record. And to set this up, first we're going to leave this field blank. Next, we're going to browse for the actual mail server itself. Okay, and we created an actual host entry for this. So once again, we're not entering an IP address. This computer, it's going to have its own host name with an IP address. You just have to go out and specify which host record it actually is. So now you see that we're referring to the host record mail.wiredbraincoffee.com. Mail server priority is important if you have multiple different Exchange servers. You can set a higher priority on one or another, so when a request comes into a mail server, the one with the highest priority is going to win out. Let's take a look at how this works. Here you see our mail exchanger record, or MX record. Okay, and it's referencing mail.wiredbraincoffee.com, which points out here. How this works, if you get an email request that's sent to, let's just say joe@wiredbraincoffee.com, that email is going to come in and it's going to be referencing the DNS server. Now, it's referencing the DNS server because it still has to go by the domain name, wiredbraincoffee.com. When the DNS server sees that it's Joe at, that at keys it off, it knows that it's looking for a mail server. The DNS server is then going to reference its DNS database looking for an MX record. Once it finds its MX record, pointing to mail in our case, it's then going to return this as the IP address to whichever computer requested that. Once that happens, then the computer that sent the actual email is going to know the exact IP address of the mail server to send it to. Okay, our next concept is going to be round-robin DNS. And this is typically enabled by default, but what we want to do is double check this, make sure it is enabled. So we'll go to the properties of the actual DNS server, and you go to the Advanced tab, and just make sure that Enable Round Robin is checked here. Okay, and by doing this, what you're doing when Round Robin is on, you're going to have referrals to the same host records alternated between different IP addresses. And a common usage for this is kind of a cheap fault tolerance, or cheap actual load balancing is a better description. So for example, you've got a website that you want to host and it's taking on a lot of different requests. What you can do is actually spread this website amongst 3 different servers. Okay, and instead of having 3 different host names like www, server 1, or server 2, you can use the same host name 3 different times. Let's start walking through this and we'll explain kind of as we're going. So to do this, it's very simple. We already made sure that round robin was enabled. Our next step is to actually just create a host record for www again. And this time we're going to be using just another IP address, 192.168.1.252. Oops. 252. Create the PTR record. Add host, and we're going to do one more here. www 192.168.1. We've got another web server sitting at 253. So I click add host once again. Okay. Now I'm done. Take a look at what you see up here. We now have 3 different entries for www. And ideally, you need to have a web server sitting at each one of these IP addresses. This concept does you no good if you don't have a different web server. So I'm talking about an actual different computer sitting at each one of these 3 different machines. The way this works, when a request comes in for www.wiredbraincoffee.com, the DNS server is going to realize that it has 3 host entries for www. And since round robin is enabled, it's going to alternate referrals between these 3 entries. So for example, the first request comes in, we're going to refer it out to 250. The second one will come in, we're going to refer it out to 252, then 253, then back to 250. This will allow us to load balance. So before, when maybe I had 1,000 users who are hitting my website at once, now I can split those requests up to 3 different web servers at the same time. So it's just decreasing the load on any of those web servers. Problems with this, once again, you have to have a web server sitting out here. So if we were just to add these entries and there is no web server sitting at 252 and 253, 2 out of every 3 times for these 2, they're going to get a page not displayed error. They're not going to see any web server. It's just not going to work. And the same thing holds true if one of these actually fails. So let's say your web server at 252 for whatever reason goes down, hard drive crashes or something. Well, every 3rd time, so not here, but this time, not here, every 3rd time there's going to be a referral out to a web server that's not functioning. So 1 out of every 3 users is going to get a page not displayed error. So those are some of the shortcomings of it. Positives, obviously it's very cheap, it's free. But that's just one way we can enable this round robin DNS. If you're looking for a more robust fault tolerance built into it, load balancing, the whole kit and caboodle, you can use Advanced Server and run a product called Clustering Server, which is built right into Advanced Server. In that case, in addition to having the load balancing, you also have fault tolerance. So if one of these were to go down, for example, it would automatically fail over and wouldn't send any web request out to a particular downed server. All right, next thing we're going to do, I'm going to exit off of SRv11. And we're going to go back to our internal DNS. So now we're back to client 1, and we're going to start configuring the internal DNS. So now we're back to this side. And we're going to configure SRv1 with our forward lookup zone. Let's go ahead and close this. So we're going to go back out to SRv1 now, not SRv11. And we're going to work on DNS here. Once again, this is for the private DNS structure. So open up DNS. I shouldn't have anything here as far as forward lookup zones or reverse lookup zones. Those are all cleared out. And I'm going to set up the zone for the internal network now. Okay, standard primary. If we had a domain, we could use Active Directory integrated with no problems whatsoever. So you can use Active Directory integrated on the internal side and use a standard primary on the external. There's no problem with doing that. So we don't have Active Directory, so we're just going to go ahead and do a standard primary. And this is going to be for Wired Brain Coffee, just like our external. Okay, so next, we'll keep that file name, next, and finish. We're also going to want to set up a reverse lookup zone for the network ID of 192.168.1. Come on now. Okay, click next, next, and finish. And now we're going to populate our zones with a couple of entries here. Okay, we already have SRv1. Let's also put an entry in for SRv2. Not SRvG, but SRv2. And that IP address we're going to use is 192.168.1.202. Create the PTR record, click Add Host. Then we'll create one for SRv12. Okay, down here we should have 212, PTR record, Add Host. Okay, so a simple zone for our internal network. Okay, we should have the second one here. Oh, didn't create SRv1. So what we're going to do now is go ahead and create the PTR record for SRv1 just to make sure that we have this correct. Okay, so that's, oops, it's going to be 201. And we'll go browse for the host record. Okay, click OK, and now we're all set. We've got a fully populated forward lookup zone and reverse lookup zone. Now let's just make sure that we're on the same page here. This is the internal DNS structure. Yes, it's named wiredbraincoffee.com, and this is back to what I was referring to before, that split brain DNS situation, where we have an internal DNS with the same name as the external DNS. So this internal DNS, this is going to be a database of all the internal computers. We only have 3 listed here, but realistically, however many computers you have in your network, you're going to have that many computers in this internal DNS. So there's going to be considerably more entries in your internal wiredbraincoffee.com zone than there's going to be on your external wiredbraincoffee.com zone. Next thing we need to do here is we need to forward our requests out to the external DNS server. We'll talk about why we need to do that. So I'm going to click Enable Forwarders here. And here is where you'd enter a public IP address of your DNS server. And SRv11 is our DNS server in this case, and we're not using public IP addresses for this lab. So don't be misled by this. I'm putting in 192.168.1.211, which is the IP address of our public DNS server. Okay, but normally you can't use this type of IP address on a public network. We're going to check Do Not Use Recursion, because one thing I definitely don't want is my internal DNS server going out into the internet trying to resolve its own domain names. So in this case here, by specifying that option, it is going to go ask 1.211 SRv11 for any DNS help. If SRv11 can't help out though, we're going to return a host not found error. Okay, this is definite security issue, so make sure this box is checked on your internal DNS servers. Okay, so I'm going to click OK here. And we're going to go back to our client machine and take a look at the diagram and also do a little bit of testing from there. So we're going to disconnect. Oops. Okay, now that we're back here, let's open up our diagram once again and take a look. Okay, Okay, so we have our internal DNS and our external DNS. Now the forwarder that we just set up, keep in mind this is the DNS server that we're working on right now. This is the public DNS server that we worked on previously. When a client makes a request out to www.microsoft.com, this computer is only configured, okay, to resolve names for the local wiredbraincoffee.com network. So there's no host entry, there's no zone, there's no way for this DNS server to resolve a www.espn or Microsoft.com, any type of public web entry. So we have this server forward out to our public DNS server. Okay, and the public DNS server, in addition, also then has to forward out to an ISP's DNS server, or maybe even just out to the root. Okay, so one way or another, to get this client computer connected out to the internet, we're going to have to be forwarding DNS requests, and that's what we configured previously when I showed you that server. Okay, let's go to our IP settings. Let's just double check what we have set here on client 1. Okay. Okay, 192.168.1.1, and we're pointing out to 192.168.1.201, so that's good. Good. Let's see if we have any other issues here. Nope, looks good. So our preferred DNS server right now is configured to point out to SRv1. Okay, so that's all set. Next thing we're going to do, let's open up a command prompt, and what we want to test is our dynamic DNS. So I'm going to a command prompt, and one way we can have our systems automatically register with a DNS server is to run this command. Okay, you're probably familiar with ipconfig. Okay, but here's a switch that a lot of people are not familiar with. It's register DNS. So what I'm telling my computer to do is go out and try to register with that DNS server. Okay, so by hitting enter here, okay, my computer is going to go out and says registration of the DNS resource records for all adapters of this computer has been initiated. Any errors will be reported in the event viewer in 15 minutes. Okay, so we don't really need to wait too long. We should be able to connect back out right now to SRv1 and check our progress, see if it actually registered there. So we're back in SRv1 now, and what we're going to do is take a look at the DNS console. We want to see if client 1 was able to automatically register in this zone. Okay, so let's refresh this. Nope, don't see anything here. Nope, don't see anything here. So what our ideal situation is for all the client computers in the network to automatically register. And this will happen when they reboot, first thing in the morning when they boot up, they'll go out and register with DNS. We just ran a command that's simulating that action, so just kind of re-registering with DNS. Unfortunately, it didn't work. And the reason it didn't work is for a setting that you need to make sure that you configure on any internal DNS server, and you don't configure on a public DNS server, and that's this dynamic update setting. So I need to set this to yes. I'm going to click OK, and you need to remember to do it on your reverse lookup zone as well. A lot of times people will forget to do it on the reverse side. So I click yes here, and we'll refresh right now just to show you where we're at currently. Okay, still no record, no sign of client 1. So let's go back to client 1 now. And now we're going to run that command again. Okay, ipconfig/register DNS. Same message. This looks exactly the same, just telling us that, as far as it's concerned, it's working. Now let's go out to SRv1 and see if we actually had this come up correctly. Okay, so we're looking here. We want to refresh our zones. Anytime you're ever checking this, you definitely want to refresh. And now we see the registration for client 1. So it's a very important setting. You need to make sure you enable dynamic updates here. Check over on reverse lookup zone just to make sure. Yes. Okay, so we've got that set up as well. So that's a good thing. So make sure that you have that dynamic update set up so there's no issues there. Another thing we want to talk about, and we can kind of figure this out by looking here, and we're going to reference the diagram back on client 1 as well. But one issue we have, we've set up that DNS forwarder. So our internal wiredbraincoffee.com is configured to forward any non-local request. Okay, so if there's a request for, once again, www.microsoft.com, if you look at the zones that SRv1 holds, it only holds the zone for wiredbraincoffee.com. So since it doesn't hold Microsoft.com here, it'll forward that request out to the DNS forwarder, our public DNS server. In that case, like we talked about before, that server is going to be able to forward on to another server and eventually get us our IP address. One issue that comes up though, in companies that are running split brain or split DNS, is when a client here requests www.wiredbraincoffee.com. So let's go take a look at this. I think it'll make more sense if we're looking at a diagram. Okay, back to our public diagram here. This client computer here on our internal network then requests www.wiredbraincoffee.com. It's trying to reach our company's web server. There's some information. It's very common that a public web server is used, by people out here, as well as people internally within the company as well. When this client computer attempts to connect to the server, though, what's going to happen? Okay, no matter what, it's first going to go out to the preferred DNS server every time. So it's going to come out here, ask the preferred DNS server if it knows how to resolve www.wiredbraincoffee.com. And keep in mind what we have configured here. We have a zone for Wired Brain Coffee. So this server is going to go, oh yeah, I know that zone. And it's going to look within its zone for a host record for www. And that's where we're going to have a problem, because it's not going to have a www. So this client computer then would not be able to actually access its own web server. Okay, so there's no problem with this computer accessing any other system on the entire internet. We can set that up fine, or internally here. The only issue we have is trying to access any computers out here. Okay, and the biggest one is going to be this mail server here. This web server here. So what can we do to fix this problem? Okay, easiest thing we can do is go back out to our internal DNS server. In our case, that's SRv1. And what we're going to do is configure static records here within our host records. Okay, so what we need to do is make sure we're in our forward lookup zones first. And then once we're here, we're going to create a static record for each of the different www entries to start. So I got a new host, and I'm going to type in, like I said, www, and then the IP address, 192.168.1.250 for one of them. And I'm going to put another one in here, www. And the only reason I'm putting in the multiple entries, remember we configured that round robin DNS. So now our internal clients will also be able to take advantage of the round robin DNS. Because typically you only need to put in one static entry. So there's no reason to put all of these in unless you want them to be able to use round robin DNS as well. Okay, so we'll start with that first. So let's take a look at what we've entered here. These three records, first off, it's a little bit misleading because once again we see this private class IP address, and it appears that these records are on the same internal network as the rest of these clients, rest of these host records. In reality, on a real network, these records are going to have public IP addresses, so they're going to stick out a little bit more than the rest of the records. And what will happen then when somebody requests www.wiredbraincoffee.com, it'll come here. This DNS server, SRv1, will say, yeah, I'm responsible for wiredbraincoffee.com, and it will have an entry for www. Okay, and now this IP address is returned back to the requesting DNS client, and just by going through a normal routed TCP/IP network, that computer is going to be able to participate with the web server now. Okay, so you have to put them in statically or manually, but you can make it work. So there's no issue with making that work. Okay, so to finish this out, we'll add one more record here, and that's going to be our alias record for the FTP host name. Okay, FTP, browse, and we're going to specify one of these www records anyway. Okay, so I click OK, and we're all set. Okay, so that shows us how we can do this. If we go back to client 1, let's take a look at what actually pops up here just to make sure we're on the same page. Oh, what am I doing? Don't want to shut down. Start run command, go back to the command prompt. I'm going to type in NS lookup, hit enter, Okay, so we're still able to talk to SRv1 without any problem. Let's put in www, see what we get here. Okay, we didn't show this before, but here it shows the 3 different resource records that now pop up. We see 50, 53, and 52. So we see all the IP addresses there. Let's also type in FTP. Okay, we get, once again, 3 different IP addresses for each of the different IP addresses that are hosting an FTP server. Okay, so the internal clients then, and that's what client 1 represents, remember. The internal clients are now able to communicate with www as well as FTP. Okay, that concludes the video portion of the Building a DNS Infrastructure for Wired Brain Coffee Incorporated. I hope this Mega Lab increased your knowledge of DNS, and want to thank you for using Train Signal.